Well, good morning, good afternoon, or good evening, depending on where you're located. Welcome and thank you for attending Val-Matic's webinar on our Ener-G Ball Valve for industrial applications. Your presenter today is Larry Woodworth, who is the Business Development Manager for Val-Matic for the industrial products. And that's yours truly. So you get to listen to me for about 40 minutes or so. So before I get started, I would like to do a little housekeeping. You will all be muted. All your mics are muted. And we do that because of background noises and stuff like that, dogs barking, kids playing, you know, your boss yelling at you, whatever the case may be. So, but if you have any questions while I'm talking, in the questions box, type in your questions and I will do my best to get to them as we go along. If for some reason, if I cannot get to your questions, we do have a section at the end of the program for question and answers, and I can get to them then. So bear with me, we will get them all answered. So there will be a follow-up email, and you'll receive this tomorrow. And it'll be sent to everybody, of course. And so if there's some reason I don't get to all the questions or whatever, I will make sure that I answer them in a separate email and send them all out to you. So you will get everything answered and so on. But also in the follow-up email is not only my contact information, so if you have any other questions or you need additional information or whatever, you can contact me and I'll be glad to help you out on those things. But also too is going to be a link. Now, I've done 4 webinars so far on various products for Val-Matic. And on this link will be the link to these other webinars. So you can go on there and you could view them free of charge anytime you want. They're open to the public, so feel free to go in and look at some of our other products that we have webinars on. Now, lastly, you will see my cursor on the screen, okay? And I'm moving it around right now. Unfortunately, I'm doing this on one screen. I don't have 2 screens. And so I have to run the webinar in the background. So you'll see my cursor move off to the side every once in a while. But also I'm going to use the cursor to help point out various things as we talk about them as we go through the program, okay? So you will see that as we go. Now, let's do the agenda. Now, we've already kind of gone through all the introductions and so on. I have no co-organizers on this one, so it's just me. I'm going to give you a brief history of Val-Matic. Then we're going to talk about the Ener-G Ball Valve. I'm briefly going to talk about Val-Matic's other products, and then we'll do questions and answers, and then we'll close the program. So we'll get through that. So Val-Matic, we started in 1966. The company was founded by Andy Nutter and Ted McCowan. And they started off with the silent check valve and shortly thereafter, very shortly, the air valves. And then we continued to grow after that. So we have the dual disc check valve, the tilting disc check valve. We opened up a new facility in 1985 in Elmhurst, Illinois. And literally we started in Andrew's garage. So that's how it all started. It's one of those stories. But anyway, after we built the new facility in Elmhurst, we did came out with the twin flex check valve and the cam-centric plug valve. We expanded the Elmhurst facility in 1994. Then we came out with the new rectangular cam-centric plug valve. Then we acquired the American butterfly valve from American Darling. It's an AWWA butterfly valve line. Then the Surge Buster check valve, the flood safe flow preventer and inflow preventer, sorry. The Ener-G Ball Valve, which we're going to talk about today. Then we purchased a facility in Addison, Illinois, which is about 7 miles away from Elmhurst. Depending on traffic, it could be about a 20-minute drive. But anyway, and that started off in the Elmhurst facility, we do valves up to 30-inch. And in Addison, we do 30-inch and above. And the largest valve we've made in Addison so far, I believe, is 108-inch. We have made up higher than that, but we had to go to a different facility to have them put it together and so on. But anyway, that's for the larger valves. It also houses the Quadrisphere ball valve, which we'll talk very briefly about. In 2014, we actually acquired the Quadrisphere ball valve. So all told, right now, we have 178,000 square feet of manufacturing and office space. So we're fairly good size manufacturing company, and we do manufacture all of our own valves. So let's talk a little bit about the scope of the product here. Quarter turn shutoff valve, of course, it's a ball valve. We have resilient and metal seats. We do 4-inch to 60-inch, single seated and double seated. AWOL class 150, 250, and 300. Design velocity is 35 feet per second. Now the standard this valve meets is AWOL, which is the American Water Works Association C507. Now, even though it meets that particular standard, industrial plants have water coming in and they have wastewater, sludge, and stuff on the other end of the valve, on the other end of the building. So a lot of our valves, even though they might meet AWOL standards, they also can go into industrial plants, okay, for, you know, waters and light duty stuff and that. So that's why we talk about it, so that way we can tell you that we can get them in there in other applications. The valve interior is a fusion bonded epoxy coating, interior and exterior. And that helps with any kind of slurries and sludges and a little bit of abrasiveness and those kind of things. Plus, it can handle some chemicals in that. So it is a good coating that protects the interior of the valve. So Ener-G Ball Valve is a 2-piece ball valve design. So it has 2 pieces to the body. We have grit guard seals, which I'll go over a little bit more detail. The Tri-Loc seating system, which here again we'll talk about. It either can be unidirectional or bidirectional. Okay, so either one direction or both directions. The fusion bonded epoxy coated, insert internally and externally. The energy efficient with extra low head loss. Okay, it's a full port, so no problem there. A rubber seat on the ball for flow protection. There's no shaft penetration or anything in the flowway, and no debris buildup inside the valve. And we'll talk about that a little bit more in a little bit here. The seats are field adjustable and replaceable, okay, in the field, easy. And it's a full port, so it's 100% flow area. All right, so let me pull up the first polling question we have here. So give me a second to get this launched for you. All right, we got that launched. Now, do me a favor and answer it. I'll let you have a few seconds or whatever. But the question is, do you know the difference between a shaft-mounted ball and a trunnion-mounted ball? So give me a yes or a no. All right, it kind of looks like we got everybody done here. So what I'm going to do is I'm going to share the results. So 50% said, yes, you know the difference, and 50% said no. So that's a nice split. So let me go ahead and hide this. And then we're going to go to the next slide. So here's kind of a graphic drawings of a trunnion mounted ball valve. Okay. On the left-hand side, it's a plate trunnion, generally 6-inch and above, because the ball starts to get heavy at that point. So they put it on a plate. And at the bottom, you have the plate down here supporting the ball with bearings and thrust washers on that. And at the top, you also have another plate that supports the ball. And that's also got bearings and thrust washers on that. So the stem takes no load whatsoever. So the ball sits and spins in its own geometry. Now to get it to seal, the seats are spring loaded, and the seats plus the line pressure pushes the seat to the ball to seal it off. Now this one on the right happens to be what they call a pin trunnion or a post trunnion, where the ball sits on a post on the bottom, and it is literally attached to what is the gland flanged up here with the that's holding it in place, not the stem. Okay, with the bearings and the thrust washers and so on. So here again, it sits and spins in its own geometry. Okay, so in a trunnion mounted, the only thing you're going to see on this is torque values. There's no other side loadings or anything like that on that ball. Now on a shaft mounting, the shaft actually goes into the top of the, I don't have a cutaway of this, sorry, but it's attached with a pin. And we'll kind of go over that here in a minute then on some of the features and so on. But it's pinned to the ball by this pin here, the shaft, okay? So this is kind of like a butterfly valve shaft, okay? It doesn't go through it, but the shafts kind of support that wedge or the disc in the middle, but it's able to deflect ever so slightly. So what happens with this shaft mounting ball is when it goes closed, it's sealing, but then you have that extra little movement at the end with the line pressure that gets to seal. Okay, I mean, you can't see it with the naked eye, but it's there. So it takes not only the torsional loads, but also the shear loads it has to worry about. That's why stems on these kind of valves are generally bigger than on a trunnion mounted ball valve, because they have to take up 2 different loads. Okay. Now let's go on to the next one. So let's kind of go over it. Now, for those that you don't know, we have the Ener-G Ball Valve on the left, which is a shaft mounted, and then we also we produce what we call our quadrisphere ball valve, which is a trunnion mounted ball valve. Okay, so we actually have 2, so we can go in either direction on this. So I just want to kind of point out the 2 differences. Now, just to say up front, the quadrisphere ball valve, I have already done a webinar on this, and it's on our website. So when you get that link, if you want to see what that quadrisphere ball valve is about, you can go in there and watch the webinar on the quadrisphere ball valve. Okay, so the basic differences between the 2 is the Ener-G Ball Valve is AWWA C507, American Waterworks. The quadrisphere is an API 6D pipeline ball valve. So it meets 6D, and it also meets ASME B1634 requirements. So it is a true, I guess, industrial type of ball valve that can go in pipelines and all sorts of other applications and so on. That's the other program. The body materials, the Ener-G Ball Valve is cast iron and ductile iron. On the quadrisphere, it's cast steel, stainless steel, LF2, other materials. The ratings for the Ener-G Ball Valve is AWA class 125, 250, and 300. And on the quadrisphere, it's ASME class 150 through 2,500 pound ANSI class. The seats resilient in metal for the Ener-G Ball Valve, and we can do reinforced Teflon, PEEK, metal, and other various plastics and so on for the quadrisphere. Shaft mounted versus trunnion mounted, and the ball valve moves to the seat versus the seats move to the ball. So that's kind of what you're kind of looking at, kind of like a floating ball valve, sort of. Self-cleaning seat on the Ener-G Ball Valve, no, but on the quadrisphere, yes. Both flush out the ball cavity, and we're going to go through that a little more detail a little bit later. And then the media differences is water, wastewater, sludges, and that versus oil, gas power, sludges, wastewaters, and so on. So they have a little bit of difference in the two of them. Okay, the features. We're going to start in the lower left and just kind of wrap around the valve. Down at the bottom, we have our thrust bearings. Okay, they're down in this area right down here. Fusion bonded epoxy coating inside and outside. The taper pins between the ball that holds the shaft and the ball together. The shaft sleeve bearings are in this area right here, so it keeps it nice and straight and moving. The shaft seals, which we'll go over in more detail. The body, the tailpiece, or the second part of the body. The ball. The body seat is actually, and we'll go through it again, with stainless steel. And then the resilient seating system is actually on the ball, okay? And then we have what we call grit guard seals at the top and the bottom, and that helps keep any debris and stuff from getting into the bearings and the shaft and destroying it. Materials of construction, the body. Cast iron with an optional ductile iron for the 150 class. Ductile iron is standard on the higher pressures for the 250 and 300. The flanges, pretty typical stuff, 16-1, 16-42. So in the class 150s and that. So I mean, we meet all the basic industry standards and so on. Some more materials of construction. The ball on the 150 is cast iron, but we can do ductile iron. And the larger sizes, it's cast iron for strength. The shafts are 18H stainless steel, 304 generally, or optional on 316. And then the larger ones, the 250 and 300 class is 17.4 PH stainless steel. Oh, I forgot to put the little things up there. Okay, taper pins. Taper pins are secured with a nut. Okay, you got your bolt, it's a tapered pin that goes through there, secured on the other side by a nut. What that does is it gives a real positive ball to shaft connection. So you're not going to have any play in that whatsoever. And then for the shaft seals, it's a V-type chevron packing. It's got, it's a great industry proven, design. It just compensates for wear, gives you longer life, minimal maintenance, those kind of things. So it really is a good sealing up at the stem packing of the shaft seals. The bearings. The thrust bearings are always a bronze material unless otherwise needed. The sleeve bearings, which are on the shaft on both the top and the bottom, are fiberglass backed Teflon. The body seat itself is stainless steel, and it has an O-ring so that there's no leakage or anything like that. And of course, the stainless steel gives you a long, longer longevity and stuff like that, depending on what you're doing. Stainless is pretty inert to most things. And then the actual seat is interrupted, and then the seat is actually on the ball, okay? And that's how it's, we'll explain how it's attached here in a second. So that gives you leak-free type of performance because of where it's located. So the resilient seat is generally Buna N. It's totally uninterrupted all the way around. Gives you leak-free performance. You can adjust it in the field very nicely or replace it just with a socket wrench, okay, with the cap screw here. And these are segment rings, and we'll kind of go over the Tri-Loc retention, but assures positive retention of the seat. So we got the seat here, we got the seat retaining ring, we have the ball. So we have the serrations, and we have gripping shoulders here, here, and here, the serrations. So when you bolt it all together, it holds that seat in place so the seat will never get pulled out, okay? So with the cap screw, it has a nylon mechanism in it, so it keeps it so it doesn't back off. Then the retaining ring and serrations in that. So that's all part of the Tri-Loc system. The the seating surfaces, you can either be the single seat, unidirectional, you can be downstream or upstream, and the double seated bidirectional, which is standard. So you're going to get seats on both ends, so it's bidirectional as a standard feature. So let's do the second poll question. So let me launch this for you. So this is, can the single seated valve have the seat located on the upstream side of the valve? So it's yes, no, or depends. So I'm going to give everybody a couple seconds to put their answers in there. All right, it kind of looks like we're almost. I'll give you another 2 seconds or so to put your answers in there. All right, we're going to close this out. Looks like just about everybody put their things in there, and then we're going to share this. So nobody said yes. 57% said no, and 43% said depends. Well, the answer is yes or depends, okay? It really, having the seat on the upstream side really depends on the application, okay? In some instances, you're gonna need the seat on the upstream side because of maybe backflow or if the valve's going into a header line where it's shut off, but other ones are going through and there's product or whatever, and you can't have that backwash up into that valve. So sometimes it's required to be on the upstream side. Also, too, if you want to protect your pumps or whatever, you would put the seat on the upstream side so that way the system pressure doesn't get into the pump if you need to service it or whatever, or even to, cause any problems or whatever with that. So sometimes you do need that single seat on the upstream side. So just keep that in mind and always contact your, contact us for any information on that between our inside engineers, sales engineers on the desk, or our engineering department can help you with those kind of applications. So I'm going to hide this for you, and then we are going to go on. Okay. So let's, we'll just kind of briefly go through some benefits of the valve. It's a 2-piece body versus a 3-piece, so a lot less bolting together and gasket, possible gasket leaks or whatever on any kind of 2 or 3 piece valve. Provide, structural, one less component for us to have to manufacture, and of course less weight. Okay, the double seat is the standard. Okay, it's got FBE coating as standard for long life, durability, corrosion protection. Seat on the ball design, so you can adjust it very easily in the field, or you can replace it very easily in the field. You need is a torque wrench, basically, and a socket wrench to do that. Now the grit guards. Now the grit guards are there to keep any kind of debris, solids or whatever from getting into the shaft and the shaft bearings and causing any kind of damage or locking up the valve or whatever. Okay, so it does protect the bearings and the stem from all kind of damage and abrasiveness and so on. Now, if you're going to be in a high abrasive or sludge application, for this particular valve, we would recommend that you put the valve with the shafts in a horizontal position. So that way, if there is anything that's going to be in the pipe, is going to flow more down and out rather than being caught in this area down here, causing any tremendous kind of problems. Okay, so that's just one thing that we like to do. So highlights, specification highlights is the Tri-Loc retaining system, which we kind of went over. The double seat is a standard, FBE coating, the seat on ball design, and the grit guards for sludge and gritty applications. Now, every valve that is designed and needs to be approved by AWWA has to go through a proof of design test. And we sent the valve to Utah State University, which, if you don't know, Utah State does, I don't know, I would say probably most of the testing on valves that there is, because they're all set up to do this kind of thing. They can get into really extreme flow rates and pressures and so on, but they really put the valve through the paces, and it's a third party testing facility basically. So they did their thing to it, and they took the valve all the way up and conducted at 40 feet per second flow through the valve. So they put it through its paces pretty good. So we have in-house our own engineering lab. We have a flow loop. We have 2 sets of pumps and all sorts of tanks and that. And all of our valves are also tested within our facility. As you can see, we have our valves all over the place in here, which we can isolate or test them or do whatever, depending on what's necessary. And we were also testing the Ener-G Ball Valve in our flow loop. So we did the cycle testing and the pressure leak tests and so on and so forth. Just as a side note, this gentleman right here, it happens to be our CEO and president of the company. But this picture was taken a few years ago, so but he doesn't do that anymore. Anyway, so actuators. Of course, manual gear operators or whatever, motor operators, cylinders, whatever. What's nice about Val-Matic is we are not tied down to a specific actuator manufacturer. So any actuator you have in your system, let's say if you were standardized on, Rotork or ALMA or EIM or whatever, that's what we will buy and put on the valve for you. Okay, so it doesn't matter to us what actuator you use. That's totally up to you. Now, a lot of times our local rep can also install actuators, on the valves for us too. So, but we can do that. So, just want to point that out. So, the media. slurries, sludges, wastewaters, clean fluids. All these things are in industrial plants, okay? When I first started, when we started the industrial product back in 2013, that was one of the things that I had to make sure that our reps and that understood, is that our standard ball valves can also go into an industrial plant. Just about every industrial plant that I've ever been into over the years has water coming into it, and it has wastewater and sludge and other things on the other end. So we can handle those kind of things with our valves. So I think I've got the last polling question coming up here. So let's throw this one out and see what happens. So I'm going to launch this for you. So question is, can the Ener-G Ball Valve remove any debris buildup in the valve ball cavity? So we're going to give you a few seconds to, we're looking good on this one. Okie dokie. All right, now I'm going to close this out, and then I'm going to share it with you. So here's the answers. 67% said yes, and 33% said no. Yes is correct, okay? The way the valve is designed, it can flush this cavity out, okay, every time it opens and closes. So here's, oh, I'm sorry, duh. There we go. Now we got it. So every time the valve opens and closes, it'll flush it out. Now this happens to be the animation or the flow of the quadrisphere ball valve, but it's the same for the Ener-G ball valve. Looking down on the top of the ball, as that ball goes open and closes, you now have flow around the ball, okay, because of these nice little flow paths that are created here, because the ball and seat aren't always touching. So it now can flow through there, okay? And also you can flow through the center of the valve, on the sides, and also too over the top and the bottom, okay? You have all this cutouts here. So it flushes and it cleans itself out, okay? Which is super. A lot of ball valves don't do that, and all that debris and solids and everything get caught in that cavity, and that's what causes the ball to get scratched within. Then it damages the seat and the valve leaks. And for some reason, customers don't like leaky valves. So it's self-flushing, so it cleans that cavity out. So that's a great, great tool, great thing. So now service applications. I mean, there's probably another 50 applications that this can go into, but just some of them is pump control, surge relief, pig launchers and receivers, because you need full ports mainly when you're doing that. Those pigs don't like reduced port valves whatsoever. Isolation, isolating anything either unidirectional or bidirectional. You can modulate. So we can go in a multitude of different applications. So high velocity discharge, this is kind of just one example. This is a hydroelectric dam, okay? And up here is your river, lake, reservoir, whatever, coming down through. You need a full port ball valve before you get to the fixed cone valve, which is after everything goes through the turbine and so on and so forth. This is your discharge, okay, that you always see at the bottom. So the Penstock, here's another one in a hydroelectric dam. Why I picked on this, I don't know. But here again, here's your reservoir, your lake or river or whatever it is. And it comes down, and this is probably the last valve before it goes into the turbine. So you need a full port ball valve that's going to give you full port, also shut off, that goes into the turbine. And of course, the turbine gets turned in, and it turns the generator. The generator makes the electricity, and then this all goes out to discharge. Just blow off connections. Generally, it's full port ball valves or full port valves through there. So that way you don't have to worry about anything getting caught. Pig launchers, going down that pipe, you want the pipe to be clean, so you have to have a full port valve, which is the same inside diameter of the pipe going through there. So the pig's got to go through the valve and then out, and that's what cleans all your pipelines. I was in Texas about a year ago, and I happened to see one of these pig launcher receiving areas up close and very personal with it. But they cleaned a 40-mile stretch of pipe twice a day. They cleaned it out with these pigs. So it was a very active site where they cleaned it all out. I'm just going to show you a few pictures of installations. This is a pneumatically operated ball valve in a pumping station. Off of pipelines. Whatever, there might be a check valve or a air valve or something on top there. And here's another pumping station where you need that full port valve, and it's set up. Here's a flow meter or whatever by there, and so on. So you've got to have full port, no restriction around pumps, big time. And here's another one. So now I kind of like this picture as I was putting things together, and I'm going to let you write a caption for this. Help me out on this. But my first thought was, where's the coffee machine? As he's looking around trying to, get a cup of coffee. So if you want to feed me a caption that you think might be good to put in here, I'll be glad to add it. Just throw it in the questions box, and then everybody's being shy on me today. But if you have a neat little caption that you want to throw at me later, just send me a, you got my email coming tomorrow, so you can shoot me an email and let me know. But here's kind of like a pump control automated valve. And this would be a spot where you would put the seat on the upstream side. And you would do that because you want to protect the pump from any kind of system pressure. So when this shuts off, you want to keep the pressure on this side, and then this, no pressure whatsoever. So you can work on it or whatever case may be. This is an actual picture of a pump control. The Val-Matic family of valves, I'm going to kind of briefly go through these just to give you an idea of what all we have. Now, our check valve products. Up here we have what we call our swing flex. It's a great valve for sludges, wastewaters, those type of things. It's got one moving part, okay, and that's the flapper. We can also rubber line the valve or glass line it, depending, if you got any solids or chemicals or whatever. Then we have down here, we have what I call is our surge buster, which is the swing flex with a spring. So that helps get that disc in there to shut a lot faster. We have a dual disc check valve, inline check valves. We have a tilting disc check valve, and we also have a swing check valve. Now this is a lever and weight, but we can do all sorts of, other things with it too, other options. So I'm trying to think of our family of air valves. We have valves that are suitable for, airs, gases, and so on. Then we also have for wastewaters and that. A group of, and that's to either get the air out or vacuum valves, or the combination of air or vacuum. So we, we have all sorts of different things, and there's also a webinar on this valve and our swing flex valves on the website. So you can look at that anytime you want to. Our quarter turn valves, we have our butterfly valve we've been talking about. This is great, for intakes and so on, water and so on coming into the plants. We can also rubber line that and provide a different, materials of construction. Our Ener-G Ball Valve we're talking about now, our plug valve. Here again, this is a great sludge valve. It can be rubber lined or glass lined also, but it can take the abuse, and it takes a lick and it keeps on ticking. What was the commercial for the Timex watches way back when? And I just showed my age. Sorry about that. And then our Quadrisphere ball valve, which is our API 60 pipeline ball valve, that we modified the ball to be able to take a lot more debris and stuff and not have anything clog in that center cavity. That gives the valve a longer lasting life just because of that, and also to the self-cleaning seats. So there again, that has a webinar. Our plug valve has a webinar, and our butterfly valve has a webinar. So we have a few webinars that are already done on our website that you can go and look. Okay. Now, just kind of go over our website. Of course, we have all of our product brochures there. A lot of technical information, application bulletins, different application bulletins that we've written on where valves can go and specific type of applications, videos, CAD drawings, sales drawings, instruction manuals, webinars that I've been talking about, and you'll get the link tomorrow. Case studies, all the valve specifications. So engineering companies and that, if you happen to be an engineer, our valve specification is there. So all you have to do is just, use that same verbiage or whatever to spec out the valve. White papers, our air valve sizing program, which is excellent. If you ever need to size air valves, our energy cost calculator, and any kind of certifications that we have on our various valves or whatever. So we are now at the question and answer section. Now, I do not see any questions in here whatsoever. Now, hopefully, I'm not doing anything wrong I am missing any of these. Let me check real quick. I do not see, no, I do not see any questions. So with that being said, there's no questions, then we're going to go to the end. I do appreciate you taking the time to listen to the webinar, to stop in. Hopefully I was able to give you some information about the product. Like I said, you can go in there and see the other webinars and that we've already done on the Quadrisphere, the butterfly, the plug valve, the swing flex, the surge buster, and our air valves. So this particular program will be added in about within the next couple weeks. But here again, thank you so much for attending, and we look forward to hearing from you. If you got any questions, you'll also have my email and my email contact information in the follow-up email tomorrow. So thank you very much. Appreciate it, and have a great day, and please stay safe out there, okay? Thank you.